What's up, Algebra 2? Here we are, 6.5 day 1, partial roots. Continuing on from yesterday's work with roots that always seem to work out nice. Okay, they don't always work out nice. Here we are with partial roots. So if I'm looking at the square root of 32x to the 8th, okay, we're going to break that down to 16 times 2, and then we still have that square root of x to the 8th. Okay, I can do the square root of 16, that's going to be 4. We have a radical 2 there, and then the square root of x to the 8th is going to be x to the 4th. So we'd have 4x to the 4th with a radical 2. Alright, looking at it from another angle here, we could change this 32 to 2 to the 5th power. And we worked on these previously with thinking about this as powers over roots. Okay, so then we would maybe think about it as 2 to the 4th, because the 4 is going to play nice with the square root. And then we have that 2 to the 1st left over. And x to the 8th works nice with the square root, because we're going to do power divided by root. So 2 to the 4th, 4 divided by square root means 2. 4 over 2 means we're going to have 2 squared on the outside. 8 divided by 2 is going to be x to the 4th on the outside. And then we still have that square root of 2 on the inside. And we'd get 4 x to the 4th with a radical 2. So 2 different ways to think about it and come up with the same thing. Another one here. Okay? 4th root. And we looked at different powers or different roots yesterday. With nth roots there, squares, cubes, we got up to 4ths. Okay? And you can see that 2 to the 4th is 16, so the 4th root of 16 is going to be 2. So that's a nice one. And then we have a to the 24th. 24 works well with 4. 13 doesn't. Okay. So we're going to break this up. We're going to have 16. Maybe if you want to change that to a 2 to the 4th, that could be helpful for you. A to the 24th, we said we were leaving alone. B to the 13th. 12 works nice with a 4. So let's go b to the 12th times b to the 1st. Okay? If I had b to the 12th, 12 b's in a row, b, 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 times one more b, we'd have b to the 13th power. So it's still the same thing. We're just rearranging how it looks. 4th root of 16 is 2 on the outside. 24 divided by 4, we'll have a to the 6th on the outside. 12 divided by 4, we're going to have b to the 3rd on the outside, and then we have 1 left over times the 4th root of b to the 1st left over on the inside. Simplifying with roots on the bottom. Okay, it is bad math grammar, bad math etiquette to finish your final answer with a root on the bottom. So we're dealing with square roots here. So square root of a fraction, you can rewrite that as the square root of the top and the square root of the bottom separately. Sorry. Okay. Now, it doesn't do me any good to break them up and get y to the 3rd on the outside and have a square root of y down here left, because then I still have that square root on the bottom. So what's the next nicest power here of y that would work out nice with a square root? What if it was y to the 8th? What if I multiplied it by another square root of y? And then I did the same thing on the top? Because if you multiply top and bottom by the same thing, square root of y divided by the square root of y is 1. 1 times anything stays that same thing. So now we have the square root of x to the 6th, y to the 1st. over the square root of y to the 8th. Okay, so now on the bottom I can do this. It's going to be y to the 4th. On the top, the square root of x to the 6th is going to be x cubed on the outside, and then I still have that square root of y on the inside. Okay, and that follows all of our rules. Okay, I know it doesn't look simpler, but this is how we would write it simplified. Okay, let's have you give it a shot over here with this one. Go ahead and push pause and try this one on your own. Okay, so it's pretty similar to this one, wasn't it? We're going to go square root of y, top and bottom. So now we have the square root of x to the 9th, times y, over the square root of y to the 6th. Okay, so this 9 doesn't play perfectly either, but we could go x to the 8th and x to the 1st, and then the square root of x to the 8th is we're going to have x to the 4th, and then the square root of x to the 1st, y to the 1st left over on the inside there, and on the bottom we'll have a nice y to the 3rd. All right, one more type of problem for today. Well, we might do a couple more. Okay. Adding and subtracting with radicals. All right, we're going to reduce these as much as possible. Then we're going to look for common roots, and then we're going to combine and simplify. So 98, I'm going to break that up into 49 and 2 for 7 radical 2 there. Ooh, we have a times 2 already out in front of it. 16 times 2 there. 16 is 4. 4 times negative 2, we're going to have minus 8 radical 2. Square root of 16 is 4. That 4 times the negative 2 is going to be that negative 8 or the minus 8. Okay, these are both radical 2's. 7 radical 2 minus 8 radical 2. This is like 7x minus 8x. I can put those together. 7 minus 8 for a negative 1 radical 2, or just negative radical 2. Let's take a look over here. If you think you're ready and you can handle this, push pause and try it on your own. Otherwise, we're going to work on it together here. 5 already on the outside. This is going to break apart to radical 4 times radical 3. Plus 2 already on the outside. 27, I'm going to break that down to 9 and 3. And 128. What's the biggest perfect square? 64 times 2. So we have a 5 times 2 times the square root of 3 plus 2 times 3 times the square root of 3 minus 8 radical 2. So we'll have 10 radical 3's plus 6 more radical 3's minus 8 radical 2. So we could put these two together because they're both radical 3's and finish with 16 radical 3 minus 8 radical 2. The end. Okay, so you can see how these would have, it's not complicated, it's just a lot of little steps to do. Just a lot of little steps to do. Okay, what about multiplying? Multiplying. Okay, when we're multiplying these, regular numbers times regular numbers, and then radical parts times radical parts, okay? So we can go 6 times 4 for a big 24 on the outside. And then inside the square root, 8 times 2 is going to be 16. C to the third times C to the first, we're going to add exponents together then and have C to the fourth. d to the fifth times d to the third. That'd be 8 d's lined up. D, 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 D. Okay. And this is the first one, so it's super friendly. The square root of 16 is 4. The square root of c to the fourth is going to be c squared. The square root of d to the eighth is going to be d to the fourth. And we'll have 24 times 4 for 96. C squared d to the fourth. Okay, let's have you try this one. It's going to be a little bit tougher. It's fourth roots, so be thinking about that. Go ahead and give that a shot. Go ahead and push pause and give that one a try. Okay, so we're going to do outside numbers times outside numbers. So we got a big 6 to start with there. Fourth root, 8 times 2, we got 16. X to the third, x to the fifth, we're going to have x to the eighth. Y squared, y to the third, that's y to the fifth. Okay, so the fourth root of 16. What times itself 4 times? 2 times 2 is 4, times 2 a third time is 8, times 2 the fourth time makes it 16. So the fourth root of 16 would be 2. It works perfectly. X to the eighth, 8 divided by 4 is going to be x squared perfectly. Okay, y to the fifth, not going to work perfectly with a y to the fourth, but we can maybe go 4 and 1. So we'd at least get a nice y to the first on the outside, and then we'd still have a fourth root of y to the first on the inside. Oh, not done. We can do 6 times 2. Come on, Mr. Handke. There we are. All right. And it looks like if we had some more time, we'd have some more problems to check out here. Give those a shot if you want. Otherwise, we'll be starting with those maybe in class tomorrow for examples, if you're in class tomorrow. Okie dokes, kids. Thanks a lot. Good luck. Let me know if you have any questions.